Hey everyone, so this is going to be the next lesson in the kinematics unit where we're going to talk about projectiles. In particular, there's going to be three projectiles that we'll talk about: vertical, horizontal, and angular projectiles. We're going to start with vertical projectiles because for the most part they're pretty easy. They're going to use the exact same equations that we've been using. There's just going to be a little bit of a change. We're going to start with the free fall problem where you have an object that's being dropped from some height. This could also technically take into account objects being thrown down. However, one thing to keep in mind is that with all these projectiles, there's one universal fact, and that's the fact that when it's that the objects are moving in the air, not being affected by anything but gravity for the most part. That means that there's no wings on it to provide lift, there's no engines, there's no one pushing on it as it's in the air. There's only really an initial push in the beginning, and then that's it. We kind of ignore that initial push. Um, for the most part, like I said, we're using the same equation. Now, the only thing that makes this really worthy of mentioning is the fact that there are some pieces of information that are going to be hidden in the problem, and that's kind of what we're going to talk about in this lesson is what is that hidden information. For example, one thing that to keep in mind is that whenever an object is in the air, anytime there is any sort of hint that the object is falling in the air, thrown in the air, there's nothing affecting it, no engines, we know that the acceleration is always going to be a 9.8 meters per second squared down. Or you'll see me doing this a lot. You can round that to 10 meters per second squared. The AP completely accepts it. In fact, most of the answers tend to use 10 as the acceleration due to gravity. Uh, for the most part, this acceleration is constant near the surface of the Earth. So a lot of times we use the symbol g to show that it's a constant acceleration, as long as we're fairly close to the surface of the Earth. As we get further and further out, noticeably further out, like towards space, that acceleration does change and decrease, but we're not going to worry about that now. Now, one thing to keep in mind is that this is 9.8 meters per second squared down. Uh, Remember, acceleration is a vector, and that direction does matter. And you need to make sure that when you plug this into your equations, that you represent the direction of this acceleration properly. Now, let's look at a very common free fall problem. So if you read this problem very quickly, you'll realize that there's only really one number being provided, the height, the 5 meters. That doesn't really give us a whole lot of information. If you try to plug that into the calculator, there's really nothing else you can do. However, you may notice that there is some information, again, hidden in the problem. For example, we know that this object is in the air. It's, falling in the air. So we know that the acceleration is going to be the 9.8 meters per second squared down. However, there is an additional piece of information being provided. The fact that the ball is being dropped tells us that it starts at an initial velocity of 0. So, from the wording, just that one phrase that it's dropped on the surface of the earth or dropped from some height tells us these two pieces of information: the acceleration and the initial velocity. Now, one thing to keep in mind is that direction, like I said, direction matters, but that direction is relative. Uh, our definition of what's positive and negative depends on what you consider. There have been times where I've used down as being positive and left as being positive just because it fit the problem better. It's really up to you. Now, if you want, you could just stay with the standard that up is positive and down is negative and just make your life easy. That's by all means do that. One thing to note is that it could be very useful to constantly try and visualize the question on a XY graph where everything's being, happening in that first quadrant. For example, let's say if we're doing this problem where the ball is being dropped at some height of 5 meters, I can imagine that I am on a cliff. So if I look at the XY graph, the height of whatever that 5 meters is actually at 5 meters in the positive Y direction. So my initial position, I would say, is 5 meters, positive 5 meters. When it falls down, it's going to land on the ground, which I'm defining as the x-axis. So the final position would be 0. And then, because I'm using up as being positive, I would say that the acceleration is negative 9.8 because that's representing down. It's really whatever floats your boat. You might see me kind of playing around with this in some of the problems in class. Like I said, it's really a preference thing. And that's pretty much it when it comes to vertical projectiles. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.